Hello everyone, today we're going to solve some problem about thermodynamics. So the problem is a 2 mole sample of a diatomic ideal gas expands slowly and adiabatically from a pressure of 5 atmospheric and a volume of 12 liter to a final volume of 30 liter. So the first question is, what is the final pressure of the gas? So let's find the first question. So how to solve this? How to solve this problem? How to solve this question? So we need to firstly we need to write the equation for the adiabatic process. So here P initial, V initial, gamma equal to P final, V final, gamma. So gamma is equal to we know it for the diatomic gas. Here will be 7 over 5 equal to 1.4. So we need to put it here. P initial, it is 5 atmospheric. So all these values, volumes, V initial, V final, all these values are given. We can find easily final pressure. So let's write the final pressure equal to V final gamma, P initial, V initial, gamma. So here two gammas. It means we can write it by this way: V initial over V final. Here will be gamma. So let's put the values. Initial pressure equal to 5 atmospheric, 5 times 10 to the power of 5 times V initial 12 divided by 30. So we didn't write the 10 to the power of minus 3 because here will be also cancelled. So here will be 1.4. So let's write the result of calculation. Here will be 1.38 times 10 to the power of 5 Pascal, or equal to 1.38 atmospheric pressure. So here there is the answer for the first question. So let's find the second answer. So what are the initial and final temperatures? And we need to find the initial and final temperatures. How to find it? So we need to write the equation of ideal gas law. P initial, V initial equal to nRT initial. So here we can find the initial temperature because all these values are given: initial pressure, final pressure, initial volume, and mole, number of mole, and here universal gas constant. So let's write the T initial equal to nR, P initial, V initial. So here will be 5 times 10 to the power of 5 times initial volume equal to 12 liter, 12 times 10 to the power of minus 3 meter cubic over N equal to 2 mole times 8.31. So here will be, let's write the result of calculation. Here will be 3.61 times 10 to the power of minus plus 2, or we can write it 361 Kelvin. So we found the initial temperature. It means we can find the final temperature by write this equation: P final. Also here will be P initial, V initial over T initial equal to P final, V final over T initial, right? Because number of mole is constant. So here will be final. Let's write the T final equal to P initial V initial T initial times P final times V final. So initial temperature equal to 361 times final pressure equal to 1.38 atmospheric pressure. We didn't write the we don't write the 10 to the power of 5 because here will be also cancelled. Times V final. Final temperature equal to 30 liter. 30 times 10 to the power of minus 3 over initial pressure equal to 5 atmospheric pressure times V initial equal to 12 liter. 10 to the power of minus 3. So also here will be cancelled. So let's write the result of calculation. So here will be approximately 249.09 Kelvin, or we can write it 250 Kelvin. So we found the final temperature. That was the second question. C, the third question is find the Q, heat, right? We know it in adiabatic process, heat will be equal to 0 because no heat transfer, no energy transferred into the system or out of the system. So it means heat will be equal to 0. So, and the D, the fourth question, D, change of internal energy, right? So we know it from the previous chapters. So here will be for the atomic gas 5/2 times nR delta T, because this was the change of internal energy. So let's write the put the numbers 2.5 times 2 mole times 8.31 and times delta T, T final minus T initial, T final equal to 250 minus initial 361. So here will be negative number. Let's write the result of calculation. Here will be 4,612 joule. So this is the answer for the fourth question. So let's find the last question, E, work for the gas during this process. So we write it here, Q, heat equal to 0. It means work plus internal energy equal to 0. So it means here will be work equal to change of internal energy, right? But here will be minus, right? 0 minus change of internal energy. So here will be minus 4,612 joule, and here will be minus would be plus if there will be work done by the gas, because this is the expanding process, right? Volume is increasing. Here will be plus if there was the question work done by the gas, and if there will be work done on the gas, here will be minus 4,612 joule, because work done on the gas, it is the opposite number for the work done by the gas. So we found all these questions answers. So thank you for your attention.